The land of the evergreen forests, Finland and its 23 million hectares of western taiga is Europe's most forested country. Even so, its boreal forests, as we know them today in the 21st century, do not have very much in common with those from the past. For example, recurring forest fires used to play a central role in shaping the forest landscape. By doing so, they also supported species adaptations and the development of a varied and specialized biodiversity.
In boreal forest, fires are part of the natural dynamics of the ecosystem, and they create diverse habitats for numerous species, rare and red listed. For example, specialized insects, they sense the smoke from the fires and come to the site. Then woodpeckers come to feed on those insects. The dying trees can support thousands of species, including some deadwood-dependent fungi, and also the surviving pine trees can eventually form some really valuable ancient trees. And well, also some wild berries and mushrooms that are edible, they also benefit from the fires. So in other words, fire brings wealth of life to boreal forests.
For centuries, fires have burnt Finnish forests, sometimes relatively frequently, such as the driest pine-dominated forests, or those in higher locations with higher chances of being struck by lightning. Elsewhere, Finnish forests could burn every 200 to 500 years, or at an even longer interval. During the slash-and-burn cultivation period, forest fires were more frequent, only to become effectively suppressed from the 1950s, along with the intensification and mechanization of land uses.
In eastern Finland, we have large forestal areas, and there's a risk of big forest fires. Also, in eastern Finland, there's a risk for the fire to spread between the countries. In eastern part of Finland and western part of Russia, there's a large unit forestal areas, and they are some kind of forest corridors with which the forest fire could spread between the countries.
As the climate is warming up, conditions for more forest fires might be about to change radically. According to the Intergovernmental Panel on Climate Change, the projected annual warming estimated for the end of the 21st century is 5 degrees Celsius in the Arctic and boreal areas. In that scenario, drier and potentially more windy conditions would dramatically increase the risk of wildfires in the boreal biome. This unprecedented challenge calls for new strategies and tools to monitor, forecast, and mitigate those risks.
One practical example would be laser scanning data that allows us to really see into the forest and analyze its 3D structure. So here at Arbonaut we are making maps that can, for example, tell the likely areas to burn, or if a fire can progress to a really dangerous canopy fire. This information, of course, can be used for preemptive actions by the property owners or authorities, but also for real-time forest fire simulations in case of a fire, so evacuations, property protection, and other response actions can be planned better, even using your mobile phone.
Within the Biokarelia project in Nature Research Institute Finland, we developed and applied several new tools. We are working with the drones, mobile laser scanners installed on the drones, on humans or machines, multispectral cameras, thermal cameras. Those tools are allowing us to collect tree-wise forest inventory information, not only information about the trees, but also to measure the temperature and moisture of the trees and for each single tree. A combination of those data sets allows us to develop forest fire forecasting model to forecast time and location of the future forest fires, but also if the fire will start, how it will develop, and what kind of consequences will be for biodiversity, forest owner, and carbon footprint.
Together with a warming climate, there is a possibility that forest fires will be increasingly perceived as a societal threat only. This could hinder the acceptance of their ecological benefits and use as a habitat restoration measure that promotes biodiversity. All will depend on how frequent, severe, and extensive they will eventually become in the future. The ongoing development and continuous improvement of forest fire forecasting tools and techniques will prove to be useful in mitigating those risks.